Why don't birds or squirrels on power lines get electrocuted?
In order to get electrocuted on a bare wire, a bird would have to be in contact with objects that had two different voltages. The difference in voltage along the wire over the distance between the animal's feet is very small. The animal would be in danger only if it made contact with both a high voltage wire and the ground, or a wire connected to ground, low voltage. Then there could be a large current through its body.
What is the Mach number?
Ratio of a velocity to the speed of sound.
What holds the quarks together in a proton or neutron?
Eight different massless force carriers called gluons exert the force that holds quarks together. Gluons are members of the boson family. Bosons have integral spin while quarks, electrons, and neutrinos have half-integral spins and are called fermions. Bosons can be created or destroyed, while fermions can be created only if an antifermion is also created. A single fermion cannot be destroyed unless an antifermion is simultaneously destroyed.
What is additive color mixing?
Combining blue, green, and red light to form other colors.
What are the major limitations of gnomons and sundials?
This kind of clock cannot be used at night of when the sun doesn't shine. To remedy this problem, timing devices such as notched candles were created. Later, hourglasses and water clocks, clepsydra, became quite popular. The first recorded description of a water clock is from the 6th century BCE. In the 3rd century BCE, Ctesibius of Alexandria, a Greek inventor, used gears that connected a water clock to a pointer and dial display similar to those in today's clocks. But it wasn't until 1656 when a pendulum was used with a mechanical clock that these clocks kept very accurate time.
What is a pinna?
Outer ear. A cartilage flap that forms a transformer to match the impedance of the sound wave in air to that at the end of the ear canal.
Where did the term horsepower originate?
The term horsepower came from Scottish inventor James Watt. The value for a unit of horsepower was determined after what made an extensive study of horses pulling coal. He originally determined that the average horse was able to lift 33,000 pounds of coal 1 foot in 1 minute. The conversion between watts and horsepower, HP, is that 1 HP equals 746 W equals 0.746 kilowatts. In the United States, automobile engines are rated in horsepower, while in the rest of the world kilowatts are used. In a hybrid car, the power of the gasoline engine is usually measured in HP, while the electric motor is measured in kW.
How does a synthesizer imitate any musical instrument?
A synthesizer is an electronic device that generates, alters, and combines a variety of waveforms to produce complex sounds. Often a piano-type keyboard allows the musician to select the notes to be constructed. Synthesizers may use electronic circuits to create the tones or use software that controls a circuit that converts a digital number to a voltage. Some synthesizers use a computer rather than a keyboard to select the notes. The computer can then control electronic circuits through the MIDI interface. The most common method of creating the synthesized sounds is to use a frequency modulated synthesis that creates higher harmonics that match those of the musical instrument being imitated, or create an entirely new musical sound. Instruments also have characteristic attacks, sustain times, and decays. Attack describes how fast the amplitude rises from 0 to its full value. Sustain times describe how long the tone amplitude remains the same. And decay describes how the amplitude decreases at the end of the played note. Synthesizers can create hundreds of different sounds, typically called voices.
How much resistance do our bodies have to electrical current?
On average, the human body has an electrical resistance between 50,000 and 150,000 ohms. Most of this resistance is across the skin. If the skin is wet, the resistance drops to about 1000 ohms. If the skin is broken, then resistance across organs in the body is on the order of a few hundred ohms. In this condition, 10 volts is sufficient to cause serious, if not fatal damage.
If this were the case, wouldn't riding a bicycle do the same thing?
The real reason why a car is a safe place to be when struck by lightning is because most cars have metal bodies, which act as Faraday cages, keeping all the electrical charge on the outside of the car. Since the charge is kept on the outside of the vehicle, the person sitting inside the car is kept perfectly neutral and safe. It is the shielding of the metal car body, and not the rubber tires, that protects people in automobiles.
Does a compass sometimes point downward along with pointing north?
For hundreds of years, navigators using compasses noticed that on occasion, the compass pointer would try to point downward in addition to pointing north. This phenomenon, which went unexplained for several hundred years, was observed by compass maker Robert Norman. He found when flying over the poles one end of the compass would point downward. He understood that the problem was that the pointer was attracted to the pole under the plane. By making the compass rotate in the vertical direction, he made the first dip needle.
What happens in a parallel circuit if more bulbs are added?
In a parallel circuit, the current goes through separate branches. If another branch is added with another bulb, the current has an additional path to take. But, the battery, or generator, produces a constant voltage. So the current through the original bulbs does not change, and neither does their brightness.
What is specific heat capacity?
Amount of energy needed to increase the temperature of 1 kilogram of a substance by 1 degree Celsius.
What is a diverging lens?
A diverging lens has at least one concave side. The shape of the lens causes the entering light rays to spread apart when they leave the lens. A diverging lens is often used in combination with converging lenses. Eyeglasses to correct nearsightedness use diverging lenses.
What is the Coulomb's law?
Describes the strength of the electrical force between two charged objects. F equals K, Chi Q2/R2.
What nuclear force is responsible for beta decay?
The weak nuclear force is the cause of beta decay. It is 10 to 13, 1/10 trillionth, as strong as the strong force. As a result, the half-life of most beta-decaying nuclei is long. In 1968, Abdus Salam, Sheldon Glashow, and Steven Weinberg showed that the electromagnetic force and the weak nuclear force were actually different aspects of a single force, the electroweak force.
What is graviton?
Particle that carries the gravitational force.
What if you place a rock on a table? Does the table exert a force on the rock, or does it just block the rock's natural motion toward the floor?
If you put a heavy rock in your hand, it would sag downward because you would have trouble exerting the upward force on the rock. The same happens with the table. If the table is made of thin wood, it will also sag.
What is resonance and how can it be achieved?
All objects that can vibrate have a natural frequency of oscillation. If you hold one end of a ruler on a desk and push down and then suddenly release the other end, you will see it vibrate. The natural frequency depends on the material and its width, thickness, and length. Resonance occurs when an external oscillating force is exerted on an object that can vibrate. When the frequency of the external force equals the natural frequency, then the amplitude of the oscillation reaches a maximum. This condition is called resonance. A very small external force is needed to create a large oscillation amplitude. You can explore resonance with a mass, like a yo-yo or a heavy metal washer on a string. Hold the top of the string still and pull the object to one side and watch it oscillate at its natural frequency. Then shake the top of the string at the same frequency and watch the amplitude of the oscillation increase. You will have found the resonance frequency. If you raise or lower the shaking frequency, you'll find that the amplitude of the oscillation is smaller.
Are atoms indivisible?
Thanks to the invention of the electric battery in 1800 by Alessandro Volta. 174512827, chemists had a new tool to create reactions and isolate new elements. Sir Humphrey Davy was one of the most active and isolated sodium, potassium, and calcium from their salts. But it was his assistant, Michael Faraday, 1791 to 1867, who most contributed to the discovery that the atom was not indivisible. He found that the amount of charge needed to liberate an element from a solution was proportional to the mass of the element. In modern language, the amount of charge was proportional to the number of atoms liberated. It took until 1881 for the import of this result to be realized, when Hermann von Helmholtz 1821 to 1894 pointed out that if elements are composed of atoms, then electricity could be divided into portions that could be called atoms of electricity. George Johnstone Stoney named these atoms electrons. But what were they? How was the electrical atom, the electron, discovered? Further advances came not from electrolysis but from studies of gases. In the 1700s and early 1800s, physicists used the vacuum pump, invented by Otto von Guericke in 1690. To reduce the pressure in glass tubes fitted with electrodes to allow electricity to pass through the tubes. In 1838, Michael Faraday passed an electric current through such a tube and noticed a strange arc-shaped light starting at the cathode. Negative electrode, and ending almost at the anode, positive electrode. When Heinrich Geissler was able to reduce the air pressure to about 1/1,000 of an atmosphere, he found that the tube was filled with a glow, like the neon lamps used today. By the 1870s, William Crookes was able to reduce the pressure to 1/1,000,000 of an atmosphere. As the pressure was reduced, the glow gradually disappeared. Instead, the glass near the anode began to glow. Without air to disrupt their passage, rays of some sort were able to travel from the cathode to the anode. At the anode end, they were going so fast that they caused the glass to glow or fluoresce. By coating the glass with zinc sulfide, the glow was made brighter. The mysterious invisible rays could be shown to travel in straight lines by placing metallic objects in the tube and finding that they cast sharp shadows at the anode. Because the rays came from the cathode, they were called cathode rays. Joseph John, J.J., Thomson. 1856 to 1940, conducted 3 experiments with Crookes tubes that showed the nature of cathode rays. His first experiment used an electrode at one side of a tube, out of the direct path, which was connected to an electrometer that could detect electric charge. Thomson could deflect the path of the rays using a magnet and follow their path by observing the fluorescent glow on the tube's surface. He found that the electrometer showed a negative charge, but only when the rays were deflected onto its terminal. Thus he showed that the rays consisted of a beam of negative particles. Using a tube with the best possible vacuum, Thomson next explored the effect of an electric field on the rays. He added 2 parallel metal plates to the tube, connected a battery across the plates, and found that the rays were attracted toward the positive plate and away from the negative one. In his third, and most important experiment, done in 1897, he combined the deflection of an electric field with one by a magnetic field. In doing so, he could calculate the ratio of the mass to the charge of the particles. He found that this ratio was 1,800 times lower than that of a positively charged hydrogen ion. Thus the particles must be either very light or very strongly charged. He later showed that they had the same charge as the hydrogen ion, and so they were very light. Further experiments showed that the particles had the same properties no matter what metal was used for the cathode or whether the cathode was cold or incandescent. For his work, Thomson was awarded the Nobel Prize in 1906. The charge of the electron was measured in 1909 by American physicist Robert Andrews Millikan, 1868 to 1953. Before Millikan's experiments, some physicists claimed that Thomson's results could imply that electrons had an average mass-to-charge ratio given by his experiments. but that they could have a variety of masses and charges. But Millikan showed that all electrons had the same charge, and thus the same mass.
What is an optical fiber?
Strands of glass that use the principle of total internal reflection to transmit information near the speed of light.
What is the Faraday's law?
An electric field is produced by a changing magnetic field. The field can cause a current in a wire.
What is perpetual motion?
Forbidden by the second law of thermodynamics.
Are holiday lights in series or parallel circuits?
Many years ago holiday lights used large bulbs designed to work on 120 volts. Those strings were wired in parallel. Today holiday lights are wired in series so that the tiny bulbs have only low voltages across them. If a lamp burns out because the filament fails, there will be no current through the string. But, there will be 120 volts across the failed bulb. The bulb has a wire touching the two thick wires that deliver current to the filament. The wire is covered with a thin insulating film.
How are airplane controls different from the controls in an automobile?
Automobiles travel on two-dimensional surfaces, and therefore only need two separate controls. The accelerator and brake to control the forward movement, and the steering wheel to control side-to-side movements. Airplanes, on the other hand, travel in three-dimensional space. The forward thrust on an airplane is controlled by the throttle. And the braking is achieved by closing the throttle and increasing the drag, usually by deploying the plane's flaps. Yaw, which is responsible for the side-to-side movement of a plane, is controlled by the plane's rudder. To control the pitch, or up and down orientation of the nose, the pilot uses elevators or horizontal control surfaces near the plane's rudder. To roll the plane, the rotation of the plane about an axis that goes from the nose to the tail. The pilot uses control surfaces on the back end of the wings called ailerons. The Wright brothers recognized that roll control was crucial to successful flight. They invented a method of warping the wings, creating a primitive but useful aileron.
What is chemical physics?
Study of the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions.
Are protons and neutrons the only particles containing up and down quarks?
In the 1950s, new particles with masses in between those of the electron and the proton were found. They were given the name mesotrons, where meso meant intermediate. This was soon shortened to meson. The most commonly produced meson in particle accelerators is the pi meson or pion. Pions can be positively or negatively charged or unchanged arged. In the quark model, mesons are composed of a quark and an antiquark. It is also possible to create particles with different combinations of 3 up and down quarks. These particles have higher masses than protons and neutrons and can only be created by colliding protons and neutrons together with very high energies. Examples are the combinations UUU with charge +2 and the DDD with charge -1. These particles decay via the strong interaction. The UUU decays when its extra energy creates a pair. The D quark replaces one U quark in the UUU particle, resulting in a proton, and the 5 combines with the extra U quark to form a T+.
How did chemistry contribute to the acceptance of atoms?
Robert Boyle, 1627–1691, an Irishman who wrote The Sceptical Chymist in 1661, is often considered the father of chemistry. He held that matter was made of atoms or groups of atoms that were constantly moving. He urged chemists to accept only those results that could be demonstrated by experiment. The great French chemist Antoine Laurent de Lavoisier, 1743–1794, demanded that measurements be made with precision and that scientific terms be clearly defined and carefully used. With the discovery that air contained oxygen, which is necessary to support animal life, he clearly demonstrated that air was not an element, but a mixture of oxygen and nitrogen. By showing that hydrogen, discovered by Henry Cavendish, 1731–1810, when mixed with oxygen formed water. Lavoisier showed that water also was not an element, but a compound of 2 elements. Lavoisier's care with weighing both the reactants and products of reactions allowed him to make one of the earliest statements that mass is conserved, that is, neither created nor destroyed in chemical reactions. Lavoisier's wife was a brilliant woman who assisted her husband in many ways, including translating letters from foreign scientists. He was executed during the French Revolution for being a tax collector. In supporting the guilty verdict, the judge said the Republic needs neither chemists nor scientists. Lavoisier met with Joseph Priestley, 1733–1804, shortly after Priestley discovered oxygen in 1774. Lavoisier did extensive work on oxygen and gave it its present name. Priestley invented carbonated water and experimented with ammonia and laughing gas, nitrous oxide. But when he opposed much of the work of chemists of his generation, he was pushed to the sidelines. After writing theological books that opposed traditional Christianity in England, he was forced to flee to America in 1794. John Dalton, 1766 to 1844, was an English chemist who, because he was a Quaker, could not obtain a position in a state-run university. For a number of years he taught at a college in Manchester for dissenters from the Church of England. His strengths were his rich imagination and clear mental pictures, but especially his astonishing physical intuition. His first interest was meteorology. He wondered how Earth's atmosphere, consisting of gases of very different densities, could have the same composition at different altitudes. His meteorological studies led him to the conclusion that atoms were physical entities and their relative weight and number were crucial in chemical combinations. Dalton's atomic theory of chemistry was published in A New System of Chemical Philosophy in 1808 and 1810. Briefly, it has 5 parts. Elements are made of tiny particles called atoms that cannot be divided into smaller particles. Nor can they be created or destroyed or changed into another kind of atom. All atoms of an element are identical. So there are as many kinds of atoms as there are elements. The atoms of an element are different from those of any other element in that they have different weights. Atoms of one element can combine with atoms of another element to form a chemical compound, today called a molecule. A compound always has the same relative numbers and kinds of atoms. In a chemical reaction, atoms are rearranged among the compounds, they are neither lost nor gained. The first and last parts give an atomic basis for Lavoisier's conservation of mass that he had confirmed in many careful experiments. 2 of Dalton's specifications are now known to be false. Atoms can be changed from one kind to another by the process of radioactive decay. Not all atoms of an element have the same weight. Both of these results will be discussed in the chapter At the Heart of the Atom.
What is the principle of relativity?
The laws of physics are the same in 2 coordinate systems, moving at constant velocity with respect to each other.
What is a British thermal unit, BTU?
Unit of energy often used to measure heat in homes and industries.
What are the secondary colors?
When any 2 of the 3 primary colors are mixed, secondary colors are formed. They are called secondary because they are byproducts of the primary red, green, and blue colors. Red light mixed with green creates yellow light. Red and blue produces magenta. Finally, cyan is formed when blue light and green light are added together.
What are brittle materials?
Usually break when under tension rather than compression.
What is the natural oscillation frequency?
A property of an object that can vibrate. Depends on the mass and force that restores object to equilibrium position.
What are the different states of matter?
The four phases of matter are the solid, liquid, gaseous, and plasma states. Solid phases are found at lower temperatures, as the amount of internal energy increases. The material changes from the solid to the liquid and then to the gaseous phase and finally, under extreme conditions, to the plasma state. Water, for example, changes from ice, its solid state, to liquid water, and finally to steam, its gaseous state. The temperatures at which the phase changes occur depend on the properties of the material. In the solid phase, the atoms or molecules are held in rigid positions by the chemical bonds between them. They can vibrate, but not change positions. When the temperature is at the freezing point, the solid melts into a liquid. In the liquid phase, molecules, or small groups of molecules, can move easily past one another. In most liquids, the spacings between the molecules is slightly larger than in solids, giving them a lower density. In water, however, the spaces are larger in ice than in liquid, meaning that ice has a lower density than water, so it floats. When the temperature reaches the boiling point, the liquid becomes a gas. In the gaseous phase, the atoms or molecules have essentially no forces between them, so they are free to move independently. They are about 10 times further apart than in a liquid or solid, meaning that the density of a typical gas is 1/1,000 that of the solid. To enter the plasma state, one or more electrons must be removed from the atom. Plasmas consist of electrically charged particles. Plasmas are found in fluorescent lamps, in some television displays, in the upper atmosphere, in the Sun and other stars, and in interstellar space.
What is a penumbra?
Area of a shadow where light from only part of the source is blocked.
How is the human voice similar to a wind instrument?
The vibrating source of the human voice are the vocal cords in the throat. Their vibration, at a relatively low frequency of 125 Hz, creates oscillations in the air that fills the throat and mouth. By varying the size and shape of your mouth and position of the tongue, you can change the frequency of the sound as well as the relative amplitude of the harmonics. Try it yourself. Sing a constant pitch while you vocalize the vowel sounds -a, e, I, o, and u. Note how you change the shape of your mouth and position of the tongue when you go from one vowel sound to another. Frequency. The second harmonic is twice its frequency, etc. Many instruments, especially bells, oscillate in modes that are not whole number multiples of the fundamental frequency. These higher modes are called overtones. Overtones include harmonics, but harmonics do not include overtones. Another confusing point is that the first overtone is not the fundamental. The second harmonic is the first overtone.
How did Einstein describe the gravitational field?
Einstein in his general theory of relativity showed that the gravitational field was actually a distortion of space-time caused by the mass of the object. Because space-time has 4 dimensions that are very difficult to visualize, the distortion is best seen with a 2-dimensional model. Often the model consists of a rubber sheet in which a bowling ball is placed, see illustration on page 39. The sheet is pulled down by the ball, which represents the sun. Earth is a tiny ball that is placed on the sheet and given a push perpendicular to the direction of the sun. This ball orbits the sun a few times until friction causes it to speed up and spiral into the sun. In the words of physicist John Wheeler, space-time grips mass, telling it how to move. Mass grips space-time, telling it how to curve.
What is a center of mass?
Because the force of gravity is proportional to the mass. The center of mass is at the same location as the center of gravity.
In what can charge be stored?
In November 1745 Ewald Jürgen von Kleist, 1700 to 1748, dean of a cathedral in Pomerania, put a nail into a small medicine bottle and charged it with an electrical machine. When he touched the nail, he received a strong shock. In March 1746 Peter van Musschenbroek, 1692 to 1761, a professor at the University of Leiden in Holland, performed a similar experiment with the device, now called the Leyden jar.
What is a refraction?
bending of light as it goes from one medium to another.
How fast does sound travel in different media?
A simple model that explains the main factors affecting the speed of sound is a collection of balls. Molecules, connected to each other by springs, bonds between molecules. Vibration from one ball will be transferred by the springs to neighboring balls, and in succession throughout the collection. The stiffer the springs and the lighter the balls, the faster the vibrations will be transferred. The springs are a model of the bulk elasticity, how the volume changes when the pressure on it changes. Of the material, the balls and their spacing model the density of the material. In general, the speed is slowest in gases, fastest in solids. Even though liquids and solids are about 1,000 times denser than gases. The greater elasticity of liquids and solids more than compensates for the larger density. In gases the speed depends on the kind of molecule and temperature. For air, the speed depends only on temperature. The following table illustrates some examples of the speed of sound in different media.
What is a half-life?
Time when there are half as many decays in a second as there were originally.
What is an atomic mass number?
Number of protons and neutrons in nucleus.
What is an insulator, electrical?
A material in which electrons are strongly bound to their nuclei and thus cannot move through the material.
What is the difference between the umbra and penumbra of a shadow?
A shadow produced by a large light source has two distinct regions. The umbra is the area of the shadow where all the light from the source has been blocked, preventing any light from falling on the surface. The penumbra, or partial shadow, is a section where light from only part of the source is blocked, resulting in an area where the light is dimmed, but not totally absent. During an eclipse, the region of total darkness is the umbra. No direct sunlight can reach this area, resulting in a total eclipse. As Earth rotates, the Moon's shadow races across Earth, producing the path of totality. Regions on either side of the path of totality experience the penumbra shadow and see the Sun only partially covered by the Moon.
What are examples of wheels and axles?
The screwdriver is one example. The larger the diameter of the handle, the greater the torque that can be applied to the screw. Many examples have a rope or chain wrapped around the axle. A sailing ship's steering wheel could be represented by either the left hand or the center drawing. Depending on whether the helmsman pushed down or pulled up on the edge of the wheel. The rope around the axle is connected to the rudder, which is then turned to the right or left. A similar device would be a device to lift a bucket from a well. The wheel is then replaced by a crank, but the operation of the device is exactly the same. Again, the crank can either be pulled up or pushed down to exert a force on the rope to pull the bucket up. The rear wheel of a bicycle can be thought of as two wheels on an axle. The large wheel has a rubber tire and exerts a backward force on the road, while the smaller wheel is the sprocket that the chain turns. The right-hand drawing above shows that the force of the chain is larger than the wheel's force on the road.
What is the relationship among frequency, wavelength, and velocity?
Suppose you shake a rope up and down at a constant rate. The rate or frequency is the number of times your hand is at the top of its motion per second. As the waves move along the rope, the distance between the crests of the rope, the wavelength, will remain the same. The wavelength depends both on the frequency of oscillation and on the velocity of the wave along the rope. The relationship is velocity equals frequency x wavelength, v equals x, or wavelength equals velocity slash frequency, x equals v slash f. Therefore, if the frequency of a wave increased, the wavelength decreases while the velocity, being a property of the medium, rope, doesn't change. The frequency and wavelength are inversely proportional to each other.
What alternative analog methods are used?
As was described above, modulating a carrier wave produces additional frequencies above and below the frequency of the carrier. These frequencies are called sidebands. There is identical information in the two sidebands, so many radio services filter out one of the two sidebands, resulting in a single sideband broadcast, or SSB. SSB can work with either AM or FM radios. It has half the bandwidth of a double sideband broadcast. So more radios can use the same part of the spectrum.
What is a fermion?
Particles like quarks, electrons, and neutrinos with half-integral spins.
What type of simple machine is a screw?
You can think of a screw as an inclined plane wrapped around an axle. The ancient Greeks used a screw to lift water. Screws and bolts are also used to fasten two pieces of wood, plastic, or metal together. Screws have a large mechanical advantage, and thus the distance the screw thread moves in its circular motion is much larger than the distance the screw moves into the material. Therefore, the force the screw or bolt exerts to hold the material together is large in comparison to the torque used to turn the screw. Screws and bolts are also inefficient machines because of the friction between the screw and material, or between the metal of the bolt and nut.
What is a standard model?
Presently accepted description and explanation of subnuclear particles and their interactions.
Are these the same?
Mass defined as m equals fnet/a is called inertial mass. Mass defined as m equals f gravitation/g is called gravitational mass. Many physicists, starting with the Hungarian Baron von Eötvös, have done experiments to determine if the two kinds of mass are equal and if they are the same for all materials. Recent experiments have shown that if they are different, the difference is only 1 part in 1015. Furthermore, Einstein's general theory of relativity explains that they are identical, and calls this fact the principle of equivalence between gravitation and acceleration. In other words, the laws of physics in an accelerating reference frame or a gravitating frame are indistinguishable. You can't tell the difference between falling or being acted on by gravity.
What is a calorie?
Heat, like work, processes that transfer energy, is measured in the joule, a unit named after James Prescott Joule. Although the joule is the international standard for measuring energy, heat flow is often measured in calories. A calorie defines the amount of energy needed to increase 1 gram of water by 1 degree Celsius. The energy required for 1 calorie is 4.186 joules, which is a relatively small amount of energy. Nutritionists also use the term calorie to describe the amount of energy a particular food can provide a person.
What is the focal length of a lens?
The focal length measures the strength of a lens. Consider a converging lens. Rays from a very distant object come together at the focal point. The focal length is the distance from the lens to the focal point. Lenses with very convex surfaces have shorter focal lengths, while flatter lenses have longer focal lengths. For diverging lenses the focal point is virtual. That is, it is the point from which the diverging rays leaving the lens would have come from if a point object were placed there.
What are the properties of magnets?
You probably played with magnets since you were a child. It is likely that you found that magnets attract some materials but not others. You may have found that you can use a magnet to magnetize items like paper clips, nails, and screws. If you played with two magnets you found that they could either attract or repel each other. Whether you played with metal bar-shaped magnets, rectangular or circular ceramic magnets, you found that the magnet exerted stronger forces at the ends or faces of the magnets. Those regions are called poles. If you hang the magnet from a string so it can rotate freely, you'll find the magnet orienting itself north to south. The end facing north is called the North Pole, the other the South. Like poles repel each other while unlike poles attract, but either end can attract other materials. Children often discover some of the properties of magnetism by playing with bar magnets and metal shavings. In this way, you can easily discover that magnets have opposite poles and create magnetic fields. Magnetic poles always come in north-south pairs called dipoles, two poles. Some theories predict the existence of isolated north or south poles, called monopoles. But, there have been extensive searches for monopoles over the past decades and none has ever been found.
Does lightning always strike the ground?
Although most people think of lightning when it goes between earth and clouds, the most common type of lightning occurs inside and between thunderclouds. It is usually easier for lightning to jump between the clouds than it is for it to jump from the clouds to earth. As a result, only 1/4 of all lightning strikes actually strike the ground.
What is a wavelength?
The distance from one point on the wave to the next identical point, the length of the wave.
What is a force, F?
A push or a pull on an object by an external agent, vector.
What is transparent?
Media that allows light to pass through the material. Rays of light are either not bent or closely spaced rays are bent together.
What is a drag?
Force that opposes the motion of an object through a fluid.
What is saturation?
Extent to which other wavelengths of light are present in a particular color.
How can you construct your own Leyden jar?
You can use either a glass or plastic container that has a tight-fitting cap. Use a small nail to make a hole in the center of the cap. Straighten a paper clip and push it through the hole. Make sure the end of the clip reaches the bottom of the jar. Cover the outside of the jar with aluminium foil and fill the jar about 2/3 full of water. Make sure that the jar cap is dry. Now rub a plastic pen with wool and touch the pen to the paper clip. Repeat the rubbing and touching several times. Then touch the clip with your finger. You should feel a very tiny shock. The jar has stored the charge that you gave the pen when you rubbed it.
What did Einstein do to win worldwide fame?
By 1914 Einstein's accomplishments were well accepted by physicists and he was appointed professor at the University of Berlin and made a member of the Prussian Academy of Sciences. Einstein published the general theory of relativity in 1916. Among its predictions was that light from a star would not always travel in a straight line, but would bend if it passed close to a massive body like the Sun. He predicted a bending twice as large as Newton's theory predicted. During a 1919 solar eclipse these theories were tested and Einstein's prediction was shown to be correct. The result was publicized by the most important newspapers in England and the United States, and Einstein became a world figure. In 1921 he won the Nobel Prize in Physics as a result of his work on the photoelectric effect.
What are Newton's laws of motion?
You have just explored how force and mass affect acceleration. Sir Isaac Newton, 1642 to 1727, summarized these results in what is called Newton's second law of motion. For a single force, like you used, it can be written as acceleration is equal to the force applied divided by the mass, or A equals F/m. That is, the acceleration, A, varies directly with the force applied, F. The stronger the force, the greater the acceleration. And it varies inversely with the mass, m. The larger the mass, the smaller the acceleration.
What is a tsunami?
Series of waves in water caused by underwater earthquakes and volcanic eruptions.
What happens when a magnet is cut in two pieces?
When a magnet is cut, the atoms within the domains remain aligned. In almost every case, the cut would be between two domains, leaving aligned domains in the two halves. If you cut a domain, you would create two smaller domains, each with a north pole and a south pole. So no matter where you cut, the result is two magnets, each with its own north and south pole. The more domains, the stronger the magnet.
Where did its kinetic energy go? What was the effect of the friction between the block and table?
To explore friction, rub a pencil eraser on the palm of your hand. Then quickly put the eraser against your cheek. You probably found that both the eraser and your hand became warmer. The friction between the block and table had the same effect. But the temperature change was probably too small to detect. If the temperature increases, then the thermal energy in the object has increased. Thus the decrease in kinetic energy of the block was AC accompanied by increased thermal energy in both the block and the table. The energy just changed forms. Scientists have made careful measurements of energy in a variety of forms and have always found that energy is neither created nor destroyed. In other words, the energy put into a system always equals the energy change in the system plus the energy leaving the system. These measurements have led to a law, the conservation of energy. As long as no objects are added to or removed from a system, and as long as there are no interactions between the system and the rest of the world, then the energy of the system does not change.
How can these two forces that are so different in strength and range be unified?
It only happens at extremely high energies, corresponding to a temperature of 1015 K. Such as occurred in the first few moments after the Big Bang or in an accelerator. They received the 1979 Nobel Prize for their work.
What is an electron volt, EV?
Energy particle with charge of an electron or proton obtains by being accelerated by 1 volt potential difference.
Is it true that lightning never strikes the same place twice?
This is absolutely false. The Empire State Building in New York City is just one example of where lightning has struck more than once. In some thunderstorms, the tower on the Empire State Building has been hit several dozen times.
How do we see objects?
In order to see an object, light from the object must enter our eyes. We can see stars, lightning, and light bulbs because they are emitting or giving off light. We depend on the light emitted from these sources in order to see objects that don't emit light. We see those objects because they reflect light into our eyes. The paper on which this book is printed, for example, does not emit light. We see it because the paper reflects light into our eyes.
What is a circuit?
Circular path through which charge can flow. Needs a source of potential difference, wires, and a device with resistance.
What is condensed matter physics?
Studies the physical and electrical properties of solid materials.
What is a parallel circuit?
Circuit allows the charges to flow through different branches.
What is farsightedness and what can be done to correct it?
Farsightedness, or hyperopia, occurs when the lens of the eye can see objects far away, but cannot focus in on objects at closer range. The cornea and lens of the person with farsightedness cause the image to focus behind the retina, resulting in the images from objects close to the eye to be blurred. In order to correct for farsightedness, a convex lens is used to converge the light rays closer together, permitting the image to fall on the retina. The rigidity in the eye lens that affects older people, making them unable to focus on close objects, is called presbyopia.
How much extra energy is needed to heat the pan?
The answer is found by multiplying the specific heat capacity of aluminium, 897 J/kg degree C, by the mass, 0.3 kilograms, and by the temperature change, 80 degrees Celsius, to obtain 144,000 J or 144 kJ. So the total energy needed to heat both the water and the pan is 814 kJ. Note how much more energy is needed to heat the water than the pan. Look through the list of specific heat capacities on page 125 to find other metals from which you could make a pan that would need less energy to heat it. The high specific heat capacity of water makes it a good material to use, for example, in cooling an automobile engine by circulating the water through the engine where the water is heated, and then through the radiator where flowing air can cool the water.
What is color blindness?
Some people are unable to see some colors due to an inherited condition known as color blindness. John Dalton, 1766 to 1844, a British chemist and physicist, described color blindness in 1794. He was color blind himself, and could not distinguish red from green. Many colorblind people do not realize that they cannot distinguish colors. This is potentially dangerous, particularly if they cannot distinguish between the colors of traffic lights or other safety signals. Those people who perceive red as green and green as red are known appropriately as red-green color blind.
What is a supersymmetry?
Proposed theory to solve difficulties with the Standard Model in which each boson has a supersymmetric fermion partner particle or sparticle, and each fermion has a supersymmetric boson sparticle.
What is the difference between pitch and frequency?
Frequency, like sound intensity, is a physical property. Pitch, like loudness, is a description of how the ear and brain interpret the sound. Pitch is primarily dependent on frequency, but depends somewhat on loudness. Timbre, and envelope, which will be discussed below. Humans hear pitch in terms of the ratio of two tones. The ear perceives two notes to be equally spaced if they are related by a multiplicative factor. For example, the frequency of corresponding notes of adjacent octaves differ by a factor of 2 notes. In common chords are related by ratios of 3:2, 4:3, 5:4, etc. In the same way, the perceived difference in pitch between 100 Hz and 150 Hz is the same as between 1000 Hz and 1500 Hz.